Good morning and welcome to today's electronic design webinar entitled Obsolescence Management Starts at Design, sponsored by Rochester Electronics. I'm Bill Wong, Senior Content Director with Electronic Design and Endeavor Business Media. To begin, let me explain how you can participate in today's presentation. First, if you have any technical difficulties during today's session, please submit to the question window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event. We'll answer as many questions as possible during the Q&A session that will follow the main presentation, but please feel free to send in your questions at any time. To do so, simply type your questions into the question window on the side of your screen and hit the submit button. To refer a colleague to today's discussion, share it on social media, or access event resources by clicking the icons on the left side rail of your screen. Also, please be aware that today's session is being recorded and will be available on the Electronic Design website within the next 24 hours. You'll be notified by email when the archive is available. I'd like to introduce today's speaker. Deisz is the Vice President of Design Technology at Rochester Technology. He has over 35 years of semiconductor design experience. He's the Vice President of Design at Rochester Electronics, based in Rockville, Maryland. In this role, his group performs all authorized product replication and customer-specific design solutions. Dan is also an active member of the Anti-Counterfeiting Task Force for the SIA, having trained more than 200 CBP HSI agents. Welcome, Dan. The floor is yours.
Thank you, Bill, and thank you everyone for taking the time to join us here today. And I want to talk about obsolescence management starts at design, and go through today what kind of two parts: what the semiconductor industry today is looking like, and then more about obsolescence management. So first of all, thank you, and please be aware this presentation, along with a bunch of supporting material, is all available for you to download. And so you don't have to worry about trying to remember what slides I present and so forth. The presentation today, or what I'll be talking to, is really divided into two sections. One is a kind of an update of the semiconductor market. It's important to understand where the market is to know how to work through obsolescence challenges that are coming your way. Because if you don't understand the semiconductor market or trends, you probably won't understand why obsolescence management or obsolescence management is needed. And again, the earlier you incorporate obsolescence management into your flow as a standard practice, the less expensive it's going to be for you in the long run. So let's get into it. The first of all, you've seen these kind of charts before, but I want to run through them because it's kind of important to understand what drives the market. And really it's automotive, it's portables, and then it's artificial intelligence or PC computer related, data center related. Those are the big three. Consumer in there as well, industrial, and then government, as far as defense spending and so forth, is the 1%. And for 2024, the market really went down in for most of these semiconductor companies. 2023, it went down as compared to 2022. 2024 technically increased revenues total, but it's really a select few that are tied into artificial intelligence really heavily, that saw the benefit: the NVIDIAs and the SK Hynixes, and somewhat with AMD and a little bit with Micron. But those are the guys who are seeing the growth as a result, but everyone else is kind of breaking even or struggling. And let's talk about the industry lead times, or not lifetime, sorry, as it relates to certain markets, industrial and automotive, and those things drive the average lifetime for chip. Yes, sure, there's the military side of it, which is as long or longer. But what that means is that the average lifetime of the semiconductor product, as it relates to the market, you can see the disjointed nature of the long life systems, which are industrial and automotive and government spending. So this again, AI companies showing most of the growth, but others are showing flat or much slower growth. Kind of a dramatic increase in spending forecasted for the defense market, but it's still the 1% market. It's not likely going to change the overall percentages. Even if it doubled, it'd be 2%, but it's not going to be the market for which products are defined. Products are not defined for the 1% market. They are meant to be an adjacent market. And I'll get into that a little bit when I talk about automotive. If you look at what the top 10 semiconductor companies grabbed 66, two-thirds of the market share in 2024. That's quite a bit. That means everyone else is fighting for the remaining third. And that kind of paints a picture of the semiconductor market, but also who your system should be defined using and whether or not they're lined up with the long-term markets. And you can see the compound annual growth there for the military spend is likely to pretty dramatically increase by itself. If you look at the normal ups and downs of a semiconductor market, this has been going on a long time. It even goes back way before 2008. But 2008 was the first time where you could really see a great big crash in the semiconductor market. And we see these peaks and valleys. I'm old enough to have seen all of these and a lot more. Y2K, and you kind of go back and you know cycles are part of the industry. Cycles are what happens. But we we think we're past the low in this particular cycle, but it's a slow trend coming back up. It's not a really fast trend, and it's really made tough to predict by the geopolitical climate right now going on. All you have to do is turn on the news at all. You can see this is very hard to predict when things are going to come out of it. But we do think right now, and as a normal trend, that we've already gone past the bottom. So when you look at what's happening with logic IC sales, because that's not typically the data center, you can kind of see it's flattening out a little bit coming into this first quarter. The numbers aren't out yet, but that's kind of what it looks like it's doing is kind of flattening out a little bit, but at least the trend has been upward from where it was. Some other major things that have happened here in the last year, I'll say, onsemi had a huge ASIC end of life event for long-term system companies. This was actually way more impactful than what might have been let on, but they're the last of the old-fashioned ASIC suppliers. There really isn't a company that owns a foundry or owns their own fab process who offers up custom silicon for legacy or even lower cost fab processes. That doesn't really exist anymore. That market, that custom silicon market, has really turned into something very different at this point. Um, CHIPS Act's investments, they were all leading edge silicon. Leading edge silicon is not what the long-term system companies tend to use. They tend, especially automotive guys, they don't tend to cut the bleeding edge of technology, and that means that they're back a few revisions. They're back 4, 5, 6 different generations from leading edge, and that's where their volume is, and that is not going to be foundry leading edge for long-term system companies typically. Um, PowerPC exists in avionics, but the end is near. Really everything to do with PowerPC. It's a single company architecture at this point. It's had a lot of good years, but it's pretty clear that this is at the end of the line, and that's a trend to keep in mind. The last bullet I have on here is really when you stop and think about it, HBM or high bandwidth memory, Apple, NVIDIA, Intel, AMD, all of those processors, what used to be kind of thought of as processors plus memory, is now very much high bandwidth memory, HBM memory, tied to the processor in terms of bare die, in terms of a kind of, lack of better words, a massive hybrid that is the memory bare die on the mounted next to the processor and maybe even post processing for chip to chip interconnect. Um, HBM memory is driving wafer volume. What does that mean? Well, that means you think about your DDRs and you think about what used to be next to, let's say, a microcontroller for a long-term system. Probably not going to be the focus in the long run of the semiconductor companies who fabricate memory. You think about what drives that, and that's going to be a trend to keep aware of. Automotive. If you bought a car in the last few years, and I'll spend a couple slides talking about automotive here, but it's the semiconductor content going into automobiles is pretty astounding. What they're trying to do with any kind of radar, pick your radar, lidar or whatever, sensors, everything that is continuing to increase how much semiconductor content is in automotive. The automotive market is truly, you saw it was one of the big three that the semiconductor companies care about: automotive, artificial intelligence, and portables drive about three-quarters of the semiconductor market revenue. This is the only market that is a long-term system market that everyone else who needs long-term system products should be lined up with. So if you're designing a long-term system today and you're not in the automotive market, you should be choosing automotive components. That should be what you're doing. Because if you're not, then you're not taking advantage of a market the semiconductor companies do care about for long-term system implementations. Okay. So here's one that they kind of haven't, the semiconductor companies have kind of been walking away from a little bit, and probably not calling on direct as much as they used to, and that's commercial avionics. But the need is very real here. If you look at what Boeing and Airbus are building for a backlog, as of right now, that backlog looks about 10 years. If you order a brand new plane, theoretically, you won't get it for 10 years. That's the backlog that they're sitting with, depending on the model and and so forth. So sorry, I clicked on the wrong button there. You didn't get to see this slide. So commercial avionics is a long-term market. It is one that absolutely has demand for the long term, but the semiconductor companies aren't kicking out new products for the commercial avionics market as a rule. They're not doing that. So if you're in commercial avionics, really, again, you should be leaning toward automotive products to ensure longevity. Okay. And last of all, I've got defense on here. Obviously, a big increase in defense spending in Europe. There is also going to be a large defense increase in the U.S. most likely. It's in a way unfortunate, but that's the world that we're in right now. Again, this is the 1% market. So yes, it will dramatically increase as compared to itself. It still will not drive uh, virtually any new product definition. So keep that in mind if you're in the defense industry. No semiconductor products are getting defined for your market upfront. Just not happening. Okay. And another trend in the industry, we want to talk a little bit about this. I know Rochester's heavily involved with this. We also TI, Allegro, and others. Um, Date code restrictions from fully authorized sources are without technical merit. The whole date code thing has really kind of been out there without any kind of standard attached to it. There's been contract manufacturers that have fed back, hey, we don't want anything older than 2-year date code or 3-year date code, or pick their rule. Um, what we have found, and it's starting to get a lot more attention, and we'll continue to amplify this, is that if your product is coming from fully authorized sources and always been in the authorized channel, having a date code restriction is without any technical merit. We see no technical reason to restrict date codes from fully authorized sources. And our data says 15 years, and so does TI's data says 15 years. And so it's not just a Rochester thing. So this is getting amplified, and I'm going to say that the real problem behind all this is likely to be the reality of how contract manufacturers have financial obligations and storage challenges and all that with long-term systems. That's probably the real problem. So I want to bring this up as an industry trend because that matters also when you're saying whether a product is obsolete or not. Okay, couple more slides here on industry trends, and then I'll get into why that all relates to obsolescence management starting at design. Again, the big three: artificial intelligence, automotive, and portables drive the semiconductor market. No other market segment drives what the semiconductor companies are creating for new products. And that's important to remember as you're defining your systems. Be careful what you choose, and that matters at design. Talked about this already. Just the number of chips going into automobiles is pretty outstanding. Uh, you know, compound annual growth rate, depending who you go to, who you talk to, it's 10% or higher. That's a heck of a lot of growth projected for automobile. And really within automobile, even if you take electrification out of it and assume that hybrid's really going to drive it, it's still driver assist stuff is really dominating where this is all going. A lot of growth in the different segments within automobile. Okay, to understand semiconductor product obsolescence, you really need to understand the causes, the main causes, and I like to whittle this down to what I think are the four big ones, the four major causes of semiconductor obsolescence. You got silicon or fab process obsolescence, you have package obsolescence, tester platform obsolescence. They don't want to deal with an old platform. It's costing them too much money in between maintenance runs, or hey, the platform is unsupported by the original manufacturer anymore. And the last one is usually the obvious one: revenue target not being met. Each one of these is important to understand why a product goes obsolete. Just getting a notice from them might not tell you which of the four reasons. And you're certainly not going to get the reasons if you're just talking to a distributor. You need to talk to the original component manufacturer directly, or an authorized aftermarket manufacturer. We would have that information. The original semiconductor company would have that information, because it matters. It matters as to what you do or what you can do at the time you finally receive a discontinuation notice or an obsolescence notice. And I'm not going to read all this, but you'll see here's the things that you can do for each type of obsolescence. And it might be a combination of multiples. It could be, hey, revenue targets aren't being met. No, by the way, this package is going away at the same time. So let's kill it off, or do a last time buy on it, and we're done. Each one of these is kind of, I provide a recipe as to what you might be able to do as a result. But in reality, if you're waiting to go down this path, you're late. And I want to take a slide here and just understand what happens at the semiconductor company before you've even gotten the last time buy notice. Many, many months have gone into deciding to issue that obsolescence. And the same four main reasons apply But let's pretend you're working at the semiconductor company now, and you're a product line owner. You're somebody that owns either a memory product line, a microcontroller product line, a power regulation product line, whatever. You're that product line owner, and your revenue targets are being set for the following quarter. You're being graded on what kind of return on that investment you're getting and so forth. And then you learn one of these major four things has happened or is about to happen. The fab process is going away, the package is going away, the tester platform is just not reliably being able to be run anymore, or your revenue targets are just way too low. We've got other things that we want to move this on to, or we have a follow-on product. Inside the company, they get that notice. They understand what is driving that. Now they need to go out to their sales and FAEs in the field and go poll what kind of forecasts that aren't booked in the backlog already. What do we think we're going to have for demand in the long run against this product? That could also mean now the semiconductor company goes back through their distributor and asks their distributor, what do you think the demand is? Because a lot of product lines are sold through distribution primarily, and they got to go through the distributor to find out because they might not have point of sale data, which is the end customer data, like the semiconductor distribution channel would have. So this takes time, right? All of this takes time, and sales and FAEs are now going out to the market and trying to figure out, well, what's left in the market against this product or this product line. And now that all that data comes back, revenue trends are analyzed and projected, and now a last time buy revenue bump forecast gets circulated within the original component manufacturer. So now they've received some piece of information that says it's got to go end of life here. They understand what they think the market has left in it, and now it's going to go out to the market as a forecast in the future. A lot of internal debate is happening. Salespeople who are trying to defend their local customer may be upset that a product is going to go away if there's no follow-on product to it. A lot of back and forth goes on internally. And customers with the highest direct revenue, meaning not through a distributor, not through Arrow, Avnet, Feature, Mauser, any of those guys, not through them. They're going to get alerted ahead of the last time buy. And they're going to have an alternate solution, either a special thing for them, or they're going to have a follow-on product that is going to ease them into it. And there's going to be some concessions, some time frames discussed, and so forth. But the largest customer for any given product that's going last time buy will know ahead of the last time buy notice. They're not going to get surprised with the last time buy notice. So if you're getting a last time buy notice the first time you found out about it, you're not the largest customer. Then the last time buy notice goes out to distributors and direct customers who have recently bought the product. Think about that. If you haven't bought the product for 3-5 years because you bought enough back before, during the panic of the COVID times where you couldn't get stuff and you overbought and your warehouse is full, you haven't bought for 3 to 5 years, guess what? You might not get that last time buy notice. That might not go to you. You haven't bought. So they assume you're done. It goes out to distributors, and if you've been buying through a distributor, you hope that distributor passes that on to you, but there's a delay there. So think about that timeline now. That timeline has already happened within the semiconductor company. That whole thing has already happened. So by the time you get this last time buy notice and you go, because let's say you're more reactionary than proactive, realize all this went into it. All this already happened. And by the time you're getting this last time buy notice, a lot has already gone. A lot of water's already gone under that bridge. And now you're sitting there going, now what can I do? Well, maybe nothing. Maybe nothing except buy the product. That might be your only option because you've gotten yourself down this path so far. that you're reactionary. Okay, let's talk about how all this background, all this market trend, some things coming up, and some thoughts about how obsolescence notices go out. How does that relate to obsolescence management starting at design? So, if the definition phase of winning long-term system business, so I think obsolescence begins right at the definition phase of winning long-term system business if obsolescence management principles are not brought in immediately. So I'll answer a few questions here. Where does obsolescence primarily occur? What does it mean starts at design? Why does this happen? Who can address this challenge? So where does it primarily occur? It's almost entirely in long-term system designs. And that's because short-term or consumer, like we talked about before, computing, AI markets, they don't drive obsolescence management. They don't really have obsolescence because the short-term nature of the products they're kicking out don't have obsolescence as a rule, or the volumes are so high that they're working hand in hand with the semiconductor company directly, and they don't feel the obsolescence in the same way. However, automotive, commercial avionics, industrial controls, medical, and defense, they all see it. They all feel it because aside from automotive, none of the other markets is driving product definition or longevity at all. Automotive does, but on select products. So I think starts at design means starts at system proposal and sale. Why is that? It's because systems are proposed and sold primarily with price and schedule weighed significantly higher than designing for the long term. So imagine you're in a systems company of some kind. You're trying to put together some kind of system to sell into commercial avionics or industrial controls or even defense, and you're getting judged on the price of that product development upfront and the time frame to do it primarily. If everybody thinks that way in long-term system design, you say, well, I need it for a better price and I need it faster. As a design person, here's what I would do. I'd say, okay, what can I tweak that I already did that addresses these new specifications and leverages what I did before? If you think about that, now you're going to reach back, you're going to grab something off the shelf that you had before, tweak it, modify it, and you're more likely to use the same batch of processor, FPGA, memory type that you had before because you're not given much time to kick out this product. And it wasn't the design guy that got stuck with that. He's the guy that got stuck with that. It's the system engineering and proposal people at these companies that have said, well, our customer has to have this schedule and this price or they're not going to do it. And so they commit to it. And I'll say that's right away where the bomb has been, the fuse has been lit on the obsolescence bomb. Because right there, you've already twisted your design guy into leveraging what he did. And now he's stuck with a schedule that he can't hit unless he leverages what he did before, which means he's going to pick older components that were what he did before. And so the system companies that are doing the purchasing of systems should be weighing the long-term availability, the long-term cost, the lack of obsolescence much higher right at that point. And if the design, I think, my belief is if long-term system companies were giving their design teams the ability to design for 20 years up front, you would end up with a different design. You'd end up with a different product. But I don't think they're being given that at all. Now, I just went through a lot of this stuff, and I want to emphasize very few contractual requirements for mitigating obsolescence in design. In other words, I've never seen a contract go to a long-term system supplier that says, hey, we'll award this system to you. No changes to the system are allowed at all within X amount of time. And the first reaction from a lot of people is, well, you can't do that. Obsolescence is inevitable. Yes, it is. Yes, it is. However, how you plan for that and how you design for that up front can be mitigated quite a bit. So, in other words, look, I've seen brand new systems come out using NRND components, not recommended for new designs. Does that make sense? Does that make sense for a 20-year program to use a processor that's NRND right now? I've seen it happen. And design team was given no choice. They were given 2 months to get the thing done, and that was it. Well, okay, there's your trade-off. Trade-off is you're going to inventory more parts because there's not going to be a way to get around that obsolescence. Okay, so I think system OEMs engaged in purchasing of systems can do more upfront in the bid proposal stage. I think that not enough is in place contractually, and I don't think design teams are given enough time to do it. I also think that there are standards groups out there who could do a lot more at defining what obsolescence resistant design looks like. There's no standard list out there. There's no industry thing out there that says here's what is best for designing for long-term system designs and mitigating obsolescence. There are lists everywhere. There are all kinds of people have different lists. I know that IOM certainly has some folks within different groups of IOM who have things in their own companies, but there's no standard out there that says, you know, simple things. Never choose NR&D components up front. Treat commodity products as constant change and design your board level accordingly. Adopt industry protocols instead of proprietary protocols for communication between boards or between products. Um, the only long-term system market of emphasis for semiconductor companies is automotive. So choose your components and architectures accordingly. Um, I think standards group could do a lot more at defining what that obsolescence resistant design looks like. So that's a way I think we could go forward in a better way. Okay, some conclusions here, and then hopefully have some interesting questions. The semiconductor market is cyclical. Okay, we're coming in and out of another down cycle. I didn't spend a lot of time talking about it, but you can imagine that in a downturn, what do semiconductor companies do? They prune. They prune their product portfolio, and and that's what a lot of semiconductor companies are doing right now as they're can that aren't involved with artificial intelligence and data center. They're taking a look at their product portfolio and go, we got to get out of this. This isn't going to have much more to it, and let's prune the product line. In a boom where everything is selling and all boats are floating, they aren't cutting as many product lines. They just aren't. So just be aware where you are in the cycle when you're thinking about how long are things going to last. And again, the three markets that drive the semiconductor business, really 3/4 of the business is automotive, data center, and portables. And the four main reasons for semiconductor obsolescence: silicon, fab process, package, test platform, and revenue targets. There's a recipe what to do on each one of these. But the main thing is obsolescence management starts at the bid proposal stage. There are opportunities to improve out there. I think there's contractual things that can be done more effectively. There's design for obsolescence resistance, at least a standard or checklist or something that can be put together. I think there's ways to move this forward in a better way. So with that, I'm going to turn it back to you, Bill, and ask some questions if we've got some questions from the audience.
Excellent. A few of you have already submitted questions, so we're going to jump right in. As a reminder, If you'd like to submit a question, type your question into the question window on the side of your screen and hit the submit button. Also, please stay until the end of the presentation to complete the exit survey, which will pop up on your screen. You can preview the questions now by clicking on the exit survey icon on the left side rail. So let's go ahead and jump into your questions. So to start with, is there a way to get more warning about an LTV event before it happens?
Yes. So as far as getting a warning ahead of time, I think in reality you'll see the part go not recommended for new designs. Um, Again, when you live through what I told you the semiconductor companies go through, uh, the very first thing they'll do, because that doesn't take them, not recommended for new designs doesn't put a timeline on when it's going to go last time buy, but it clearly tells you they're thinking about it. Don't don't do this. Um, and I think that's the first warning flag. As soon as it's not recommended for new designs, for long-term system companies, that should be an immediate. We're not using this anymore on anything new at all. Forget about it. And we're heading into a place where a last time buy is imminent. I better get my forecast clear and better figure out what our strategy is to work around some of this if there's a way to work around the product in question. Okay.
What's the relative trade-off in cost in terms of dollars and schedule when designing for obsolescence at the design phase versus the production introduction phase?
Yeah, that's a good question. I think when you talk about, it depends on the system complexity. I mean, I can't answer it generically, but I would say you're probably looking at a 50% increase in design time to actually design for long-term obsolescence versus what the design teams are typically given for design times. It in my experience, the long-term system companies might be giving their design team 6 months, 12 months to kick out a product, and then it's got to go through quals and all that later and so forth. So that's the true development timeline. I'm going to say that add another 50% on top of that if you want them to plan for choosing parts that are the best long-term parts, get the best life possible out of the system, and turn that around that way. That investment up front, 50% more in your design time. Yeah, if you're worried about market share and so forth, but think about that a little bit. If you mix that strategy of, okay, I'll use something quickly and then transition to my final, you just got to be thinking, how am I going to get to that point where I can allocate that time to the design team? You can't just suddenly snap and boom, then you're going to allocate and go. You got to plan it through, and there might be an incremental bridge way to do that. But that'd be my guess, is about 50% on the design time.
So what does NRND mean?
Not recommended for new designs. So when you see NRND pop up on a product on the semiconductor company's website, okay, they're contemplating this going away. So not recommended for new designs.
Speaking of new designs, what alternatives are there for the Power PC in the avionics market?
Certification with ARM sooner or later. I don't see how you guys are gonna get around that. Multi-core certification with ARM is probably inevitable. Somebody's got to step up to the plate and get that done and get the certification done, and get all that put together. What happened with PowerPC is NXP more or less mostly put all that together for everyone to have artifacts for DO254 and whatnot, and cast and all that is in commercial avionics. But the reality is somebody needs to step up and do it with ARM products in a way that then they can use. But I think multi-core ARM, multi-core RISC-V, that might be a way to go. But somebody's got to actually do the work and step up to it as an industry that, hey, we got to get this over the line because yeah, it's going to cost us tens of millions to do it, but we're going to be in the hole here, hundreds of millions on PowerPC last time by, and we're not innovating in the market if we don't jump that way.
Is the CHIPS Act addressing packaging obsolescence?
No, no, it's not. Chip Act package type investments are 3D, 2.5D advanced. You know what I heard yesterday is the Amcor investment in Arizona is actually without bond wires altogether. Think about that. No bond wires in that assembly investment going on by Amcor. Everything is related to flip chip and die attach and die stacking and so forth, and multi-die interconnect and not bond wires. So does the Chip Act have anything to do with package obsolescence? Absolutely not. And think about what's happening with package obsolescence. Your PLCCs are already gone. And that's why Rochester's invested in PLCCs. Quads are going away. Yeah, you started, 240, 208, 160, 184, and kind of work your way down the quads. They're all going to go away. Eventually, TSOPs and SOICs and all that, as the volumes drift down and everyone goes to either QFN or BGAs, or DFN or whatever, all of that is package obsolescence is going to happen, and none of that is supplemented by the CHIPS Act to mitigate.
What are the vendors or ways to identify ICs developed for automotive products to leverage the longer term life?
Yeah, they're very clear mostly. If you go look at companies like ST, like NXP, like Infineon, TI, all of those companies are really crystal clear when they talk about automotive availability, and it's a pretty clear designator that they're typically gonna say from the time of introduction to the time we'll go obsolete is a 15-year timeline. That's typically what an automotive designated automotive product will be around for, from introduction to end of life, 15 years. Not 15 years from the time you buy it, it's 15 years from the time they introduce it to the time it's going obsolete. And usually the automotive products are pretty clearly called out by the semiconductor companies themselves.
In your comment on date code restrictions having no technical merit,
Yep.
does this consider potential issues with the long term storage and solderability concerns? And what long term storage concerns are brought up that Rochester Electronics believes are manageable?
Yeah. So yes, we have a lot of studies we published out there. You can get them on our website talking about what we did when we went through the whole solderability check from products that were in our warehouse for 15 years with no cleaning of the products, and we pushed them off to a subcontractor to do board assembly on them without cleaning them, without doing any solderability checking. And what we actually found is the solderability checks that people are putting in place will unnecessarily fail products where actually mounting to the board was absolutely no problem, which is kind of related back to a fairly recent standards change, which says, hey, you can actually mount these parts on a board as a test to see whether the components are viable or not. And that's what we're recommending now. But there's a whole ton of study work that we've done that says, fully authorized stored product, which is in a controlled way, you're not going to have any issues with solderability. That's kind of an old-fashioned thing, and certainly not at the 2-year, 3-year, 5-year date code thing that's been kind of, you know, popular or pushback from the contract manufacturers. That's just not a reality. There's no technical data backing that up, where both TI and Rochester now have put out data on actually mounted parts out of the warehouse. No problem with solderability, no problem with testing at all. So I don't think we have any plastic or hermetic concerns in 15 years for anything at Rochester at this point.
Here's one for your crystal ball. How
Okay.
are tariffs expected to impact the semiconductor market, either short term or long term?
Oh, yeah. I think I'll plead the fifth on that one. In reality, nobody knows, and it's a mess right now to figure out. It's not just tariffs though; it's also part classification. There's limits on performance products, exporting performance products that are already impacting how much can be exported to what country, and so I'm going to say that. It is nobody knows, and it's a complete unknown, and it depends what each individual country is going to be doing, and can't I can't predict. No, and I don't think anybody can right now.
Okay. How long has AI been a driver in space, and what were the top three items prior to AI?
Yeah, I mean, AI has really taken over the data center. When you think about it, the data center has become an LLM processor for the most part, from a target of what NVIDIA and AMD are really targeting. The old-fashioned data center, which was primarily, about a third of it was Netflix traffic, and and uh, and and Facebook and Instagram and those kind of things with some video. That was Intel dominated, and I will say that's also been why they've uh, not been able to succeed. They weren't able to match up to what NVIDIA and AMD have kicked out as terms of AI products. So the market prior to, let's say, being AI was really data center anyway. Data center and high-end compute. It has just changed to be AI oriented, but it's still a data center. It's just the reason behind, or the compute behind it's a little bit different. And standard data center traffic has really gotten to be far less of a percentage of the compute power in a data center.
Should I expect passive components with automotive qualifications to also have an extended lifetime versus the standard commercial components?
You got some physics behind that problem that can't be mitigated just because they want it to be. Capacitors are going to have shelf life that are not going to be mitigated because of physics. There's going to be issues there. Um, Potentially, yes. Connectors, good place to be lined up with automotive. Passives, though, it kind of depends. It depends what you're talking about. Maybe I'll say maybe depends, but not necessarily.
Okay. What about allocation of components? Is this an indication of obsolescence?
Allocation, not necessarily, because it could be fab process availability if it's a leading edge product. Um, you guys have all seen the news where pretty much the 2 nanometer capacity at TSMC was gobbled up by Apple for a commit, a long term. Probably Nvidia's right in there trying to get at that latest capacity. So it depends. Allocation can genuinely mean something different at a bleeding edge versus a more mature node. Um, it can mean it's toward the end, but it just means somebody wasn't forecasting the demand and didn't have the capacity in place to be able to handle that demand. Allocation isn't necessarily directly correlated to obsolescence. That being the case, if it's a lower volume product that happens to be on the same node as something else that's a legacy node, let's say driver of the fab process, yeah, that could be an indicator. But that's kind of a secondary effect, not necessarily a primary effect. I don't think you can tie the two directly together.
Can you talk a little bit about obsolescent resistant design at the PCBA level, where you might use extra real estate so you can change to another package or part with a different pinout in the future. Uh,
Yeah, absolutely. Yes. And my favorite example is flash memory, where you know it's a commodity. It's very easy at the board level to pack those things in real tightly together because the address pins and the data pins all line up. And it's a work of art when you pack it all in. Look how tight I got this whole section of memory. But in reality, that's also moving at a commodity pace. And what ends up happening there is you pack your board in, but then the next generation of memory is going to be probably at a lower voltage, probably at a higher density. And if you give it a little space, you could do things like a power island. You could give your space, give space in the future for an interposer type design. Yeah, a company like Winslow Adaptics, I know that this is their expertise. That's what they do. I think that you're giving yourself fewer options if you pack your board in so tightly that you can't handle commodity changing. And that would be my advice: is if you know a product is a commodity ahead of time, don't pack it in so tightly that you can't move with the change, or keep it on a daughter card, or do something else. Um, I think that there's ways to do that design up front. Now, if your whole thing is size driven, then you're going to be limited on what you can do there. But know that up front, and plan for that accordingly.
okay. Anecdotally, what do you think the total cost is to a business who inadvertently designs in something that is on the verge of obsolescence? And on the macro scale, how large of an industry issue would this be?
Yeah, this is all going to depend on the cost of change in your industry. So if you look at something like in the medical instrumentation area, if something changes, what's the cost to requalify up front? And you start taking those requal costs into effect. That's your pain. That's what you're costing up front by not doing that. It's the cost of change. If your cost of change doesn't amount to much, you're in a market that doesn't have an issue with product change. You want it around a long time, but you really don't have a problem changing it. Then that's not going to weigh in as heavily. And so upfront, maybe you're better off planning refreshes all the time, because you can. You don't have the great big qual barrier that if you change anything, you're going to have to go through a ton. So it varies per industry. I think if you're in commercial avionics, the cost of change is extremely high, especially if you get anywhere near software. That's just going to ramp through the roof. Cost of change in medical instrumentation extremely high. Industrial controls can be. They can also be readily changed. It depends what part of industrial controls you're in. But I know bigger companies that are kicking out, like ABB and Rockwell Automation. When they kick out a big system in a factory automation, changing something in that is a pain, because now custom software has been written to implement whatever, and they don't even know the original system supplier, ABB or Rockwell Automation, for example. They don't even know what software is being written on those machines. Then the cost of change is really high, because now you can't know. So it varies with every industry. I'm not trying to duck the question. It's just that for every industry, it can be a lot. For some of the industries I know Rochester's dealt with, cost of change, long-term system companies, $5 million, $10 million of a change, not unusual to see those type of numbers.
How do we get data from OCMs directly if we're not in the big three? We generally don't get a lot of life cycle data when we go to the OCMs.
Yeah, and I think that you'll get so much out of a tool, right? I mean, Accurus and Silicon Expert and the guys, you'll get so much out of them. But I think partnering up with somebody like Rochester is a good thing to do. We might have additional insight in there. And I think begging begging from the semiconductor companies might be helpful, but I think partnering up with a real long-term um, system company, as a long-term semiconductor company, can help. Certainly not going to have all the answers, but we'll have more than most, especially when it comes to long-term availability. I think trying to go through a standard distributor that's graded on turns ratio, a publicly traded distributor company, that might be your worst answer, most inaccurate. They're incentivized to sell you the latest and greatest, not necessarily to keep you going. So I think that's the advice. Get with a long-term system supplier. Your contract manufacturers might have more insight. Your J bills, those guys might have more insight as well. Try going there. Sometimes they'll have product lines that pull a lot more volume than what you will typically.
Is it better to plan for a second or third source rather than obsolescence management at the design state?
Yeah, I mean, I'm going to say that that's not realistic. Second or third source, when you think about what the semiconductor companies are really trying to do, they're trying not to be second source to anybody. Every product they kick out is 100% unique. So what does second or third source mean? For commodity products or standard logic products, yeah, that's fine. But that's not really truly driving your obsolescence cost either. It's the really sticky stuff that's closer to the system software. It's your processors, your FPGAs, your custom higher end analog, RF parts, and so forth. That's what's driving your cost of change. It's not commodity products that can be second or third sourced. So I'm going to say that's kind of a fallacy path. Second or third source, that yeah, that's a long time ago. I mean, that's 70s and 80s type of thought. But right now, remember, every semiconductor company is trying to make sure all their products have no second sources. Again, the things that are driving them are to be unique, and so that's what they've done over the last 20 years. I'll say is they've made themselves incredibly unique on everything: packages, pinouts, silicon design, fab process. Everything's been unique, uniqueified.
You talked about it a little bit before, but what about discretes?
Yeah, unfortunately, Rochester doesn't deal with discretes too much, so my input is more anecdotal hearsay. Discretes are a challenge no matter what you do, especially when it comes to capacitors. I think that discretes also are not going to drive your redesign cost. They aren't any discretes are nowhere near system software. So when you talk about obsolescence management and so forth, yes, discretes are a problem, but they very typically aren't going to drive what your problem is for cost. And yeah, they might drive a board change, but a board change is a heck of a lot better than a software change. And yeah, I know some industries freak out. Oh, we can't have any board change at all. Yeah, I get that. But touching your software means your whole product goes away. So I'm going to say, nah. My take on discretes is that's not what is driving your obsolescence cost.
Other than selecting automotive grade components and avoiding NR&D parts, what choice can designers make and what processes can companies implement to build some immunity into obsolescence in their product design? For example, are certain component manufacturers better about predicting and communicating their end of life? And is there a better to work at the die level whenever possible?
Um, I'm going to say not at the die level, no. And there's lots of reasons that'll take a whole nother webinar as to why die level is a bad philosophy going forward. Um, from a semiconductor manufacturer perspective, it's everybody who's calling on automotive are the best guys to deal with. If in the U.S., I know that Analog Devices and TI have consistently been there for the long term. Absolute consistency that way. But you got your STs, your Infineons, and your uh, NXP, somewhat all kind of going down that path of long-term availability for select pieces of their portfolio. And I think those are the guys to align with. You look at the other ones. I'm going to say, your major guys, NVIDIA, Intel, AMD, they aren't. They are not lined up. And I would say Lattice is a good, FPGA CPLD type of company to align with, as opposed to Altera Xilinx. And that's just my personal take on things, but that's what I've seen. So there are companies to align with that are better about long-term availability than others, and that's also a good thing to do.
Okay. In the 2019 IEC 62402, it suggests that considering modular designs. How do you see this happening with FPGAs, CPLDs, etc., on the boards? Is there a standard guideline that can be followed?
Yeah, I don't see that. I first of all, I haven't read the standards. I don't really know that standard myself. But if you're talking about modular designs, I don't think in the end it's going to change your equation as to when you go obsolete, unless at the module pin level you've adopted some kind of industry standard protocol for communication between that module and the motherboard or whatever you're talking to. If the protocol itself isn't standard and it's just regular IOs through a connector, you haven't done yourself anything, because then the module has just as much obsolescence impact as the motherboard. If you resort to a standard PCI Express, whatever, then you've got options to be able to redesign that module or change that module out if it is 100% communicating through an industry standard. But if it's not, I don't know what you've done there. I don't think you've done anything.
Okay. What does NCNR indicate the parts are likely to go end of life soon? Actually,
Yeah, it kind of answered this already a little bit, but NCNR absolutely says your parts are going to go end of life, and it's a question of when. And they're doing all that homework behind the scenes as to when they're going to shut it off, and they're gathering up the feedback and they're gathering up the forecasts and they're making their decision as to when. It's not if, it's when. And they all go obsolete over time. But NCNR means we're into the final throes here of determining exactly the date. Um, and I would say that's your big red flag. If it's NCNR, they've already made the decision it's going to go away. It's just a question of logistically how can they turn it off and still address the biggest customer or customers on the product in the right way.
what do you think about the recent PET and PEN material obsolescence?
Yeah, I mean that's certainly going to impact. We did a study internally and we found we're not uh, supplying any of that, but yeah, that absolutely could come in and impact products all at once if they have if it's what I'm thinking. It's the new regulation that they're trying to get rid of. What is it? Polyfluoro, whatever those are, materials. PFAS. I think it's related to PFAS. If it's not related to PFAS, then I've completely misunderstood the question, and I don't know.
Okay, well, I'm afraid we've run out of time for those questions we didn't have time to answer. We'll be getting back to you via email. This concludes today's presentation. On behalf of Electronic Design and Endeavor Business Media, I'd like to thank Dan for presenting and Rochester Electronics for sponsoring today's webinar. And of course, all of you for joining us. Have a great rest of the day.